My dear students, so in this lecture video I am going to tell you about the Lagrange interpolation function. Okay, so Lagrange's interpolation function is nothing but what, suppose this function, Lagrange's interpolation functions are used only when the number of nodes present in the given elements are more. Okay, so if number of nodes are more in the given element, then you are going to use the Lagrange's interpolation function to calculate the shape function for that particular element. Okay, so here we are going to derive the shape function for two elements, that is cubic element and quadratic element. Okay, so this syllabus. Okay, so Lagrange's interpolation function I told, so it is used to derive the shape function is to use the Lagrange's interpolation polynomial. Okay, wherever you are, if you want to find the shape function, you are going to use the Lagrange's interpolation function. Okay, so this method is very good suited for to derive the shape function for an element having the higher order number of nodes. Okay, more than 6 8, then you can use this Lagrange's interpolation function. Okay, so this Lagrange's interpolation function at node k, so we are going to have the two formulas. Okay, so in the Cartesian coordinate we have the formula L of k suffix k into x is equal to pi of n I, which is equal to 1 and I is not equal to k, so that is x minus xi whole divided by xk minus xi. Okay, so this is the formula you are going to use when you are going to solve by using Cartesian coordinate, and when you are going to use by using natural coordinate, you are going to use this. Okay, natural code, this symbol. Okay, so I already told you natural coordinates, so maximum shape function value is 1 and minimum is minus 1. Okay, so summation of all those shape function which is equal to 1. Okay, so you are going to use almost in the FEM only this natural coordinate system, because it is very easy. Okay, so the function is what, pi of n is equal to what, so I which is equal to 1 and not equal to k, so zeta minus zeta I whole divided by zeta k minus zeta I. Okay, so these you are going to understand these two formula while solving the problem. Okay, coming to the derivation. Okay, so here I am going to derive the element stiffness method is shape function for cubic bar element. Okay, so here derive the shape function for 4 noded bar element, that is a cubic bar element. So this is a cubic bar element. Okay, this is belongs to the bar element now. Okay, so using the Lagrange's interpolation function. Okay, so that is the cubic, the figure shows what, the cubic 20 bar element. Okay, so having the nodes are what, 4 nodes will be there, 1 2 3 4. Okay, I already told you the maximum value in the shape function for natural coordinate system is what, maximum is plus 1, minimum is minus 1. Okay, so total, so this is minus 1, this is the value is this at node number 3 value is minus 1 by 3, and fourth is minus 1 by 3, and this is equal to plus 1. Okay, if you add summation of this means you are going to 1. Okay, so at node number 1 zeta value is minus 1, at node number 2 zeta value is plus 1, at node number 3 zeta value is minus half of 1 by 3, at node number 4 zeta value is equal to 1 by 3. So you are going to consider the coordinate system from middle. Okay, so center of the given bar element. Okay, so the shape function of the 1D cubic bar element is found by using a Lagrange's interpolation function. Okay, that means what, so in the natural coordinate system, if you derive means you are going to use this formula. Okay, so zeta minus zeta whole divided by zeta k minus zeta. Okay, so now for the 4 noded quadratic bar element, so here n is equal to 4, and hence when k is equal to 1. Okay, so simplify this, n1 is equal to zeta, or which is equal to 1 comma zeta. So if you consider 4 means, okay, so here substitute this k, okay, in this equation for the 4 noded element. Okay, 3 to 1. Okay, so this is zeta 3 zeta 4 zeta 2, neglect about this minus 1. Okay, so zeta minus zeta 3 zeta minus zeta 4 and zeta minus zeta 2. Okay, so whole divided by zeta minus zeta 3 into zeta 1 minus zeta 4 into zeta 1 minus zeta 2. Okay, so here we know the zeta 3 value, zeta 4 value, zeta 2 value, and zeta 3 zeta 4 zeta 1 and zeta 2 values from the diagram. So substitute with all the values, you are going to get the shape function for at node number 1 n1 zeta is equal to minus 9 by 16 zeta square minus 1 by 9 into zeta minus 1. Okay, so like this you have to calculate the shape function at each element. Okay, so when k is equal to 2, then you are going to neglect this zeta minus zeta 2. Okay, in the formula. Okay, so zeta, the function changes for the node number 2 is equal to zeta minus zeta 1, so this 2 you are not going to consider, so zeta 3 zeta 4. Okay, so here in the horizontal you have to take the zeta 2 minus zeta 1, zeta 2 minus zeta 3, zeta 2 minus zeta 4. Okay, so same this formula, how you are going to solve previous problem, same formula you are going to use here, and substitute the values, you are going to get the shape function at node number 2 is equal to n2 zeta is equal to 9 by 16 zeta square minus 1 by 9 zeta plus 1. Okay, so this is the shape function at node number 2. Okay, so like this you have to solve the shape function you in the each node 1 2 3 4. When k is equal to 3 means here going to neglect the k 3 value. Okay, so again from beginning, in the last you start from 3. Okay, so here take the 2, start from 2, like that you have to first you write the formula, substitute the values, then you are going to get the shape function for each element. Okay, so similarly you have to calculate the shape function for at node number 3 when k is equal to 4, so k neglect here and start from 4 here, 4 minus 1, 4 minus 3, 4 minus 2. Okay, so like that you have to substitute the formula here and the values here. Okay, so in the respective zeta values, so you are going to get the shape function of each node. Okay, so that is n1 n2 n3 value. Okay, so this n1 n2 n3 are called as the shape function at each node. Okay, so here the coming to the last, the shape function variation. Okay, so since here the 4 elements are there, so this is 1 2 3 4, this is the combination of all the 4. Okay, so at node number 1 the zeta value is maximum at node number 1 is, so here route number 1. Okay, so here coming to the node number 3 and 4, the zeta value is going to become 0. Again at node number 2 again also variation takes place. Okay, like this. Okay, so again coming to the second element, the zeta value, that is the shape function value is maximum is here at node number 2, so right here positive, so again it going to like this. Okay, coming to the node number 3, the maximum value is here. Okay, so at node number 3 is the plus 1 will be there, so right here like this log variation. Okay, at node number 4, so the shape function value maximum at plus 1 at node number 4, so like this you have to write. Okay, so these are the variation of shape function diagram. Okay, so this is the combination of all this, the fourth one, so n1 n2 n3 n4. Okay, so like this the variation of the curve going to takes place in the this what cubic bar element. Okay, so this is very important. Up to now here you can draw the, you can solve the problems. Okay, so coming to the second derivation. Okay, derive the shape function for 3 noded bar element, that is a quadratic bar element. Okay, use the Lagrange's interpolation function. Okay, so if you want to use the Lagrange's interpolation formula, means you have to calculate in the local coordinate system only. Okay, so let us consider the 3 noded 1D bar element. So this is a 1D bar element, so having the node 1 2, so middle 3, so I told, so the axis will be considered from center only in the what, in the natural coordinate system. Okay, so here 0, so okay, so this 1 2, so here look at, so at 1 at node number 1 zeta value is minus 1, at node number 2 zeta value is equal to 2, at node number 3 zeta is equal to 0. Okay, so from this to this distance is x1, that is displacement here, and from this point to this point x3, from this point to this point x2, and the length of in between these means x2 minus x1. Okay, so this is the origin. Okay, the shape function of the 1D cubic bar element is found by using Lagrange's interpolation formula. We have this. Okay, similarly how you did in the 4 noded tetrahedral element, same like we have to solve here. For 3 noded quadratic bar element, let us assume n is equal to 3, so again you have to skip. Okay, so here the when k is equal to 1, so here you have to skip the 1 value here. Okay, and start 1 from downward. Okay, so L1 of x is equal to n2, n1 minus x is equal to, formula is what, x minus x2 minus, okay, into x minus x3, x1 minus x2, x1 minus x3. Okay, so here you substitute the values here. Okay, so x1 x2 x3 value you substitute. Okay, so like that when k is equal to 2 and when k is equal to 3, these are the shape function for at a different node. Okay, so in natural coordinate system, so again same formula, so consider, let us assume n is equal to 3, so k is equal to 1, so n1 zeta L1 zeta is equal to zeta z, so this one you have to neglect here, and you start from the downward, start from 1. Okay, substitute all the values, you are going to get the shape function at node number 1 is equal to n1 zeta is equal to what, zeta minus zeta 1 by 2. Okay, so writing this formula is very important here. Okay, so when k is equal to 2 means you have to skip the 2 from the numerator, and denominator you start from this. Okay, zeta 2 minus zeta 1. Okay, so substitute zeta 1 zeta 3 zeta 2 zeta 1 values here in this equation, so you are going to get the shape function at node number 2, so that is n2 is equal to zeta, so zeta plus 1 divided by 2. Okay, so like this you have to calculate the shape function at each element. Okay, shape function at node number 1, shape function at node number 2, shape function at node number 3, that is n1 n2 n3. Okay, so after getting n1 n2 n3, so you have to write the all the in the final direction, so in the final values, that is the shape function for the quadratic bar element what, so n1 is equal to zeta, so already we derived this n1 n2 n3. Okay, so these are the shape function at a different node present in the cubic bar element. Okay, so coming to the variation shape function diagram. Okay, so this is a variation of shape function. This once if you calculate the shape function for each element, then go for calculating the variation curve. Okay, so here look at for the first element the n1 is maximum, so here from this point to this point n1 shape function value is maximum, at node number 3 is 0, at node number t is also 0. Okay, so like that you have to draw curve, you have to draw the shape like this. Okay, so n1 is equal to zeta minus 1 by zeta 2. Okay, so coming to the second element, at node number 2 is the shape function is maximum. Okay, at node number 3 and 1 is minimum. Okay, like this you have to draw the curve. Okay, coming to the third node, so third node maximum shape function is 1 here, so here you have, at node number 1 and 2 become 0, so like this you have to draw curve like this. Okay, so after substituting the zeta value here. Okay, so at now this is the combination of this. Okay, so just 1 2 3 you combine this, you are going to get this direction, this diagram. Okay, shape function variation. Okay, in examination you can draw either this diagram, one diagram, or you can draw the 3 diagram. Okay, so like this you have to calculate the shape function of the different element, that is quadratic and cubic bar element, with the help of what, the Lagrange's interpolation function. Okay, so this is very important, Lagrange's interpolation function for the point of examination. Okay, they may ask you around 8 more question in the examination. Okay, how you are going to calculate the shape function with the help of Lagrange's interpolation function. Okay, so here main thing is you have to remember the formula, these two formula. Okay, So suppose if nothing they are asking means you can use this formula, that is in a natural coordinate system Lagrange's formula is equal to L of k zeta, which is equal to pi zeta minus zeta I whole divided by zeta k minus zeta I. Okay, so this we are going to use to calculate the shape function for natural coordinate system. Okay, this you can use. Okay, as compared to this method is very simple. Okay, so I hope you understand the Lagrange's interpolation function for what the cubic element and quadratic element. Okay, so I hope you understand this. Thank you.